Welcome to the Manufacturing Engineering Media webinar presentation, The Machining Center Selection Process, Why Your Next VMC Should Be an HMC, sponsored by Akuma America. Hello, I'm Jim Sawyer, Executive Editor at ME Media. Before the presentation begins, I'd like to provide some background on what we will be doing today. Our sponsor is Akuma America. Akuma is a world leader in CNC machine tools and machining process optimization. It is industry's only single-source provider with the CNC machine, drive, motors, encoders, spindle, and CNC control it offers, all manufactured by Akuma. Our presenter is Jim Ensley, Machining Center Product Specialist at Akuma America. Jim has been in the machine tool industry for better than 30 years. His experience includes manufacturing as well as distribution and sales. With a background in heavy industry machining, including die mold, aircraft, locomotive, construction equipment, and more, as well as a knowledge of universal and 5-axis machining and a degree in business, Jim's expertise is as broad as his experience is deep. Rest assured, Jim knows his way equally as well around both horizontal and vertical machining centers. In his presentation, Jim will explain how HMCs can help improve quality, reduce changeovers and setups, and increase your shop's flexibility while maximizing floor space. Now, before we begin, a few housekeeping notes. You will be able to ask questions of Jim during the presentation using the Q&A box that appears at the right of your screen. Time permitting, these will be answered following the presentation. If time runs out before we can get to all the questions, we will make sure the answers are emailed to you. Also, Jim's presentation includes a video clip. As with all videos shown over the internet, the quality of the video depends in large part on the viewer's bandwidth and the number of people accessing that bandwidth. If you experience difficulty during the presentation, please let us know via the Q&A app. Also, if you have any questions about other aspects of our webinars, please email me at jsawyer@sme.org. I will rejoin you after the presentation with a few concluding remarks. Now, here's Jim Ensley of Akuma America. Jim?
Good afternoon, everyone. Sorry, we had a little technical difficulty. I'm assuming everyone can hear me now. Okay, let's start at the top here. I tend to make these decisions from a business standpoint and a technical decision if I'm a business owner. Certain things that I want to look at is to increase my shop throughput. When I ship parts, I get paid. It's pretty much that simple, even for a Fortune 500 company. I want to improve quality always, separate myself from my competition If I'm a two-man job shop or I'm a Fortune 500, it makes no difference. I want to separate myself from my competitors. And reduced overall costs. Now, often these decisions get made in the front office for the larger companies, and there's a disconnect I'm finding in our manufacturing world between the supervisors on the floor, the operators, and the owner-manager. They use a different language sometimes, but if you will really stop and think about it for a moment, the need to be more efficient is the same as to increase throughput. I am a strong advocate of team decisions, so I hope that we have several different groups of people on here to help that. So what we find out is that we have common goals, and that's often missed in today's world from a business standpoint. So the first question that I usually get when I start these questions is, horizontal machining centers are always more expensive than verticals, and how can I justify this investment? That's a very good question. So we're going to detail some of this today. Let's start with an industry fact, and these are not Okuma facts. As you will see on the screen, the average VMC utilization, spindle utilization, is 25%. And as we go through this, that number will make a great deal more sense than just hearing 25%. And again, these are not Okuma numbers. These are from studies from American Machinist and the University of Michigan. HMC utilization is routinely 85%. We'll detail why again, but I hope that makes us think why and why not right now. Historical and current practices. It's been my habit over the years, and it's served me very well. My experience has taught me that to know where you're going, you have to know where you've been. So there's certain ways that things get done today, and I ask a simple question when I'm interviewing prospective customers or manufacturing people: why do you do it that way? It's a simple question. The number one answer is because we've always done it that way. You're trapped in a box when you say that. So some what I call box problems. Years ago, we used to use knee mills, drill presses to do much of the work today that we still do, that we do on vertical machining centers. That just hasn't changed because that's the way we've always done it. Vertical machining centers are optimally used on large flat parts, just like the old drill presses and manual knee mills, that type of thing, for a single operation. We continue to do this, however, on vertical machining centers for small prismatic parts. Almost across the board, the places that I visit have a 6 by 6 by 6 square as an example, and they're doing that in a lot of operations on a vertical machining center. And I think as we go through this, you'll see what I'm talking about, that this is best run on a horizontal machining center. Historical practices. If I have a part with 6 sides to be machined, and I want to do it on a vertical machining center, I am looking at 6 to 7 times handling that part. As an operator, I have an operator in front of each vertical, sometimes an operator in front of 2 verticals, but normally an operator in front of each vertical machining center. Why does this continue? Because we never back up and look at our process. Once that job is running, we move on to the next one. This causes productivity. There's 2 things with productivity. There's profit and losses. Inherent VMC problems that affect productivity are each part movement uses up available spindle time. The operator cannot have his hands in the working cube to load and unload parts with the spindle running. There's a lot of safety on machines today. That just simply can't happen. Each part movement requires direct labor. I touched on an operator in front of each VMC. I am direct labor when I work for you, and when I touch that part, I cost you money. Increased capital investment. If my volumes go up, I have to buy more vertical machining centers because I'm not running very efficiently. I'm only at 25% spindle utilization time. and increased opportunity for quality problems and errors. I am a human being, and I make mistakes. It happens every day. Sometimes it's fixable, sometimes it's not. But a good rule of manufacturing is that if you scrap a part, it costs you 3 times as much to make it. Not double, 3 times as much. As I said earlier, each time a human being touches a part, it adds cost. There is no value added to me touching a part in a manufacturing environment. And in fact, it's an uncontrolled cost that increases every year. I am standing in front of a machine working for you, and if you don't give me a nickel on the hour raise or a quarter on the hour raise, I'll go down to the road to your competitor and work for him for a quarter more on the hour. I am an uncontrolled cost, and especially in today's world with insurances and that type of thing. I'm very expensive, and you can never pay for me. So why is this? Why do we continue to do it this way? That's the question. Let's compare this to an HMC solution for just a minute. If a part is machined on 6 sides with a horizontal machining center, it's only touched by the operator 3 times. If you're touching it more than that, you need to consider your setups a little more closely. I've eliminated, basically I'm inbound to the pallet to fixture number 1, fixture number 1 to number 2, fixture number 2 outbound, and I'm going to get paid for that part then. With load-unload internal to cycle, and this can be accomplished in 90% of the applications that I've seen. Why not look at it this way? Again, it's the way we've always done it. Well, what just happened here? Oh, there it is. Productivity gains is what we're after. Load and unload, as I mentioned, is internal to machining cycle. I can load 20 or 30 parts on a fixture and usually keep up with that spindle. 4-part moves requiring direct labor are eliminated. Capital investments are greatly reduced, and we're going to touch on that a little bit more in a few more slides. Quality problems are, if I'm touching the part less, I'm having less quality or chance for error problems. Those are greatly reduced. Opportunity for unattended operation. If I have long cycle times on a horizontal machining center, your operator can do other things and become more productive. You're empowering your go-to guys to do more. Why not look at this again? There's my why and why not question again. A lot of this you probably already knew. These arguments have been around for a very long time. So why is the HMC the right machine for much of your general/short-run work? We'd like to detail that a little bit more as we go along as well. Something that people don't realize, if you do the mathematics and the economics and the lost production, all the factors that go into manufacturing, traditionally in many applications, again, these prismatic parts especially, you can replace 3 vertical machining centers with 1 horizontal. This is a great idea. So if productivity is equal or better, which would you rather have? 3 vertical machining centers on the left with 3 operators, or 1 horizontal with 1 operator? Let's detail why we can do this. Potential advantages versus the VMC again. Pardon me. Spindle utilization. Fewer machines require less capital investment, and that's pretty serious numbers now today. Remember the 25 versus 85 rule? That's almost enough justification right there in most instances. Shorter manufacturing throughput times isn't in the very beginning of this. That's something that we were all trying to achieve. Setup times, internal machining cycle. Quite often people look over this. There's a lot of different ways that we'll detail to help that even. Load, unload, and time internal to cycle, we touched on that. Less in-process work. In-process inventory is not our friend. I visit many, many shops that have pallets and pallets sitting around on the floor of half-completed work. Let's take a prismatic part for a moment, like we talked about on verticals for just a bit ago. Each time I move that part, I have in-process work. Sometimes I see 3 verticals with 3 different operations and 6 or 8 pallets of half-finished work sitting around. That inventory costs you money in floor space. Floor space is so very valuable in our manufacturing world today. You cannot afford to tie it up with something that doesn't make money. Efficiency, traditionally short cycle times. And we'll talk about that a little later in some fixturing ideas. Reduced operator attendance time. For instance, if I've combined all the cycle times from 3 verticals, I have a lot of extra time on a horizontal machining center when I'm running all of these parts at one time instead of individually. Your go-to guy, again, can be empowered to do other things, maybe run 2 vertical or 2 horizontals at once. Now I've got the 85% with 2 machines instead of 3 machines at 25 with 3 operators. The big feature of this is controlled and predictable manufacturing costs. Every month I know what my costs are, and if I can control my cost, it's found money in the manufacturing world. Lower operating cost. We're back to good business sense again. 1 operator versus 3 or 4. We've just touched on that, how much money I cost you. Work in process, I touched on that. I have seen that cut as much as 75% in a lot of manufacturing operations. Inherently higher quality, less chance for human error that we touched on. Reduced fixture cost. And people think that horizontal fixturing is very, very expensive. We're going to touch on some ways to eliminate that thought process in a few slides. But would you rather tool up 1 machine with universal machining, or universal fixtures rather, or would you rather have 3 or 4 machines to do the same work with the additional cost of 3 or 4 fixtures? You get more for your investment. You empower your go-to people, as I've been talking about, with a tool that can make them 3 to 4 times more efficient. So in all, I'm increasing efficiency, I'm reducing operating costs, you can grow your business and increase profitability. That's what running a business is about. Let's look at a few examples. I've asked these questions quite a bit, and I changed this slide just around a little bit, but you see a small prismatic part up on the left-hand corner of the screen. This is a valve body. This is a real customer part, and they were doing it on 5 operations of vertical machining center. And actually, their volume went up, and they had 6 verticals doing this part to catch up, to keep up with their customers' volume. The part on the right is a 6-sided prismatic part that was being run on vertical machining centers, 6 operations per machining center. And my favorite part is a valve body. Pretty common now you see today with oil patch going through the roof and other fluid control devices. This was 3 lathe operations and 3 operations per vertical machining center. This particular customer, because it's a little bit tricky inside some of the geometry of this part, had 3 manual engine lathes running the lathe operations on this, and 6 VMCs running the drilling and tapping, basically, with this machine. His volumes went up, and he could not keep up and was in danger of losing this job. I sat down with him for a couple of days, actually, and we looked at better ways to do this job, and you'll see the results of that in a moment. Why do we continue to do these things? How about, for the first part, multiple finished parts each time the pallet shuttles? Not difficult to do. This customer gained efficiency, throughput, and reduced overall costs. What you will see on the right side is a universal tombstone fixture. It's commonly known in the industry as a Swiss cross. You have 4 sides with relief on the corners so you can get your spindle close to the part to machine. It's a nice rigid setup. The part that you see setting on that universal fixture is a top plate with a part mounted to it. The plates were loaded full, offline, internal to cycle, snapped onto the tombstone, and that was load unload, complete. That was all done internal to process. When it comes back out for unload, you simply take the plates off, snap full ones on. Why not arrange something like this? Now we'll address some fixture costs here. Everybody thinks that a horizontal is more expensive to tool up. You should only have to tool up a horizontal pallet with a universal fixture one time. And a lot of these are off the shelf nowadays. They're not special. You can make top plates in-house if you wish. Second part, fixtures don't get more simple than what you see in front of you. This is a 6-sided part. There are basically 4 vices with 2 pockets per vise set up on a horizontal machining center. This is an off-the-shelf fixture. His operators are very, very used to using vices on horizontal machining centers. The horizontal machining center, on verticals. The vertical machining centers this customer was using had 4 vices per setup on each table. All we did was take his 4 vices, stand them up on a horizontal machining center, and we did not alienate his operator. The operator was very comfortable with the setup. And from that, we used universal tooling. We reduced his cycle time and very, very simple setups. A vise doesn't care what part it's running. Universal fixturing like this can run a multitude of jobs, and you can amortize the cost of that fixture against 20 or 30 jobs if you like. It all depends on how sharp your pencil is and how creative you are. Now we get to my favorite little part, the last job that we talked about. We're back to our little valve body. The lathes that this customer was using used special chucks. They're cantilevered chucks. They're counterbalanced. He had highly skilled operators to turn in particularly the seats of this valve. Very operator intensive. And as I mentioned earlier, that was times 3. That was a problem that he had. He had multiple setups on VMCs, again, very operator intensive, special fixtures for holding the part, that type of thing. This customer's volumes went up, and his cost had to go down with a decreasing cost contract that he had with his customer. He was about to lose this job when we sat down. There was some convincing that needed to be done with this customer. He'd never had a horizontal machining center before. So I asked him to think out of the box. He thought he still had to have lathes and a horizontal machining center. How about a horizontal machining center with turning capabilities? Yes, they exist. No special unbalanced condition, no special chucking, special tooling or fixturing, no multiple machines and multiple setups. One cycle gave this customer one complete part, and he was load unload internal to cycle, as we mentioned, and no operator attendance. This simply ran without an operator there. What we used was a feature called Akuma Turn Cut. It actually does lathe operations on a horizontal machining center. And you hopefully will see that here comes the video. The best way to describe this feature is to see it run, and that's what you're about to see. Effectively, Turn Cut synchronizes the spindle RPM with the XYZ axes and always keeps the tool perpendicular to the work, and you actually do lathe functions. We've already threaded, we've done ID, OD, complex shapes, all of this works. It's a very unique software. Again, the message here is not so much about turn cut, but thinking out of the box. What you're seeing now is it shifts. He was using a special tool because of the volume on this particular part. It shifts. It goes to the ID because there was a very, very tight concentricity. Sorry, I almost forgot the word. Concentricity requirement between these two with very, very simple fixturing for the tests. And that part was complete. One of the big questions I get normally when I start talking about horizontal machining centers is flexibility. Everyone in the world today for many, many, many years are comfortable with VMCs because they're used to that type of thing. They probably trained on manual equipment that was vertical. So people are very concerned about flexibility. Honestly, a horizontal machining center is 10 times more flexible than a vertical. Again, thinking out of the box, we have a customer running parts that you see on the left on pallet number 1 and a totally different job running on number 2. There's no law that says you have to run the same job on both pallets. And the right one is interesting because you see a lot of parts, a lot of blank parts on one fixture. There's a little known rule with horizontal machining centers that if you can get 20 parts onto the tombstone, you amortize all of the idle times to 0. So if you've got, let's say, 3 minutes of tool change and slide time, and that spindle start up, ramp down, ramp up, you can amortize all that to 0 by dividing that number by 20. That's normally a good working number. So you take idle time completely out of the equation. With a vertical, that is extremely difficult to do. And if you do it, you normally can't afford 20 parts on a fixture. Your load-unload time is not internal to cycle, and your costs go up. This is unique to a horizontal machining center. Why not multiple jobs running at one time? Frequently asked questions. Isn't pallet tooling more expensive? There is an initial investment, but you don't have to spend millions of dollars tooling up horizontal machining centers. Cutting tools and rotating tooling are the same. 40 taper is 40 taper today, or 50 is 50. I tend to work over the years with the KISS factor. So if you look at some of these examples, the first one with the cylinder head on it, that is a homemade Swiss cross fixture. The gentleman saw a picture and actually made it on his horizontal machining center. And it hasn't been off that horizontal machining center in years. The cheapest fixture you'll ever have for a round part is a 3-jaw chuck on a T-stone fixture. And if you're comfortable with vices, you don't even have to buy the off-the-shelf. This, on the other side of the 3-jaw chuck of this, you have in the middle, is a vise strapped to a T-stone. Why do you need expensive tooling? Amortized cost across multiple parts. Again, the vise on the far right does not care what it's holding. Less cost involved than multiple VMCs. Actually, the ideas for everything you see here came from vertical machining centers and were simply applied to a horizontal. So the comfort level with everybody in the shop is still there. Now let's say that I want to get into horizontal machining centers. I stop here and talk about a progression in manufacturing. I go into a lot of job shops or even Fortune 500 shops, and I see maybe 5 vertical machining centers. The next thing I see is let's say they're pretty old. You can see, they bought one last year or a year, and then 2 years later they bought another, then the next year, depending on how their business was growing. But you see an evolution. I see vertical machining centers, somewhere between 3 and 5. Then I see a relatively new horizontal machining center. The light bulb came on that I keep showing in all of my little slides here. And they realized horizontal machining centers are the way to go. If I come back in a year, they generally have 2 horizontal machining centers, and 2 or 3 of the verticals are either gone or standing idle. We all learn as we go. Once I get into horizontals, there are ways to make those more efficient as well. So what's the next step after I convince myself I need a horizontal machining center? FMS is on the rise very, very quickly now. What I'm talking about is flexible manufacturing systems, pallet pools or flexible FMSs. The advantages, unattended shift operation. I can load up 30 or 40 pallets over a couple of shifts and get a free shift with absolutely no operator. Literally today you can turn the lights out and go home. That used to be a buzzword in the industry back several years ago now, 10, 15 years ago, and it never got off the ground because the technology wasn't there. The technology is here now, today. It's been here for a while. It's now tried and true. People are rediscovering FMS. I would estimate that 30 or probably closer to 35% of the horizontals that we sell at this company are accompanied by FMSs. Reduced floor space requirements. We talked earlier, we touched on that. Everybody in manufacturing today has the golden shoehorn out trying to fit more machines in less space because brick and mortar is so expensive nowadays. And it's a very long ROI. The machine tools will be paid for many times over before the building is. And yeah, I'm including power and that type of thing in the building. Commonly, with FMS utilization, it's 90% plus. I see numbers of 95 to 98 regularly. Minimal direct labor costs. Sometimes I have 2 customers that are literally loading and unloading pallets half a shift, and the rest of a 3-shift day is all profitability. The machines run unattended. Now I'm in nirvana. I have fixed cost, higher throughput, quality control, on-time deliveries. All the things that we were shooting for happen automatically. The systems today, you really have to work not to achieve these numbers. Once I look at an FMS, what kind of features should I look for? Well, features and benefits. Any feature that doesn't present a benefit to me, I'm not interested in. That's not spending your money wisely. Future expandability is huge. Most people start with FMS today with 1 machine and 1 small FMS. If I cannot expand this later, I bought the wrong FMS. Have to ask these questions in the beginning. There's no reason today that you cannot keep expanding. We have a customer in Virginia that bought a 1-machine system. He's expanded to 4 machines and a 53-pallet system over the last years. You can just, it's like an erector set. You can just keep building it. Multi-machine capabilities. You want to know for the FMS software, is it connectivity is a big byword today or a buzzword. It needs to interface with your current business systems. There's no reason that it should not be able to do that today. Offline monitoring. If I'm running unattended and I'm sitting at home watching the news or whatever, or my favorite football game, my phone should ring and tell me there's a problem with that system so I do not lose 2 or 3 shifts of production. And I'll call somebody because I want to watch my football team. Real-time optimization software. This is not as complicated as it used to be. Now the PC controller can optimize my tool paths and my jobs. I tell it I need this job by next Friday. It will find time in the system to do it. A system that can't do that today is the wrong system. And your personnel operator interface. Graphics help. It should be easy to work with because you're starting a brand new system. It's human nature to be a little standoffish of it. It needs to be easy. If I make your job easier, your efficiency goes up. Finally, I'm looking for local support, reliability, flexibility, and the latest technology. Why not look for these things? What are the barriers to success? Justification, common misconceptions about FMS. I can't justify the expense. If you do your homework beyond current spindle utilization, that's nearly enough to justify FMS and horizontals. You have to compare accurate manufacturing costs, such as current and future labor costs. Remember, I cost you more money every year. Cycle times, setup times, current quality problems, in-process inventory. All the things that we've touched on should be considered when you're looking at changing from a vertical to horizontal or even FMS. You'll find out it's very, very easy to justify. One of the common complaints is, I don't have enough volume for FMS, when in fact, 65% of all FMS sold today go to job shops that never know what's coming in the door next. The FMS is flexible manufacturing system. You should be able to run anything on it quickly, and there's always plenty of time on an FMS for setup. It's very important for low volume manufacturers to be able to deliver on time quickly and not spend a lot of money doing it. You can't afford the expense for low volume. They are some of the largest beneficiaries of FMS, the people that grasp this concept. I'd invite you to consider some of the points that we've discussed today, especially if you're looking at your next machining center investment. I would like to for you to bear with me just to tell you a little bit about the Okuma product. We offer a complete line of horizontal machining centers. We start at 400 millimeter pallets, and we go up to 1.25 meter pallets, which is not listed here. We're introducing that machine at IMTS. 50 taper, high speed, 40 taper, pretty much everything is needed today. We also offer the Pallet Ace single source FMS from Okuma. It's very easy when you build your own machine to build your own FMS, and there's no interface problems, and it can be retrofitted in the field, which is rather unique in today's industry. So I'm going to ask you to remember one thing if you don't remember anything else from the seminar today. This is something that I was told years ago when I was an apprentice, and it's stayed with me ever since. It's kind of my motto that I live by. If we don't do something different, how can we expect different or better results? That's nearly the definition of insanity, if we don't do something different. And please, as you go through your manufacturing day, look around your shop. I ask you one last thing to consider. Why and why not? At this time, I'd like to open the floor for questions. I'll turn you back over to Jim Sawyer.
Thank you, Jim. And as he said, this is Jim Sawyer joining you again. Before we get to the questions, I'd like to apologize for those of you who did experience some audio difficulty with the program today. And to let you know that half an hour after this presentation ends, an archived version is available. You can use the same credentials and link to sign in to hear it in its entirety and pick up the parts that you missed. And I also suggest that you would share that link with your colleagues who are interested in this topic and can make use of the information. We have received some questions, and it would be nice if we can get to them before our time is up. So let's start. Let's start with one very basic one, just so we're all on the same page. And Jim, would you define a prismatic part, just so everyone knows what you're talking about there?
Certainly. A prismatic part is basically a square part, and that is about 99% of what we run today. There's two types in our estimation. There's large flat parts, a tabletop, a notebook-sized part that everything gets done from one side, maybe two sides. Prismatic parts are basically a cube That's what we define those as, and many of them have work done on 5 or 6 sides.
Okay. I think you touched on this a little bit, but the technology that you discussed today, how much of it will be on display at IMTS?
Everything that I spoke about today as far as technology goes and much more will be on display at the Akuma booth at IMTS. We're introducing universal machining up there, a brand new 5-axis machine. I personally don't like to use the term 5-axis. I use universal machining techniques. It's an industry fact that less than 5% of the people that have 5-axis machine tools actually do simultaneous 5-axis motion. Most of it is what we call point and shoot. So we will have that machine there. We will also have a horizontal machining center there with a pallet pool. This is the first step prior to to FMS, is a pallet pool. It's much simpler, less investment, for example. And we will be introducing the large machine, which is a horizontal machining center that I talked about. They come in all shapes and sizes. This particular one would be a 1.25 meter pallet. In addition to that, we will have a lot of control technology. Controls are advancing rapidly. We are introducing a multitude of new control features to help with some of the problems that are facing manufacturing today.
Okay, very good. Another question here. What about when an operation on an HMC takes 7 hours, but it could run on, let's say, 4 verticals and each op takes 1.5 hours? I could complete a part in 1.5 hours once the, quote, line is wet, end quote. Your comments on that, Jim?
I won't argue that point because you're getting internal machining cycles. However, the horizontal would set up in about probably 40% of the time as the verticals, and I think you will also find that if you look at this from a business standpoint, you're going to spend much less money on fixturing and that type of thing with a horizontal than you would a vertical. There's 2 sides to every coin, so to speak. I understand the throughput. This becomes simply a matter of how fast you can ship a part. So if your throughput, you feel the throughput is higher, there are still verticals on the marketplace for that very reason.
Okay. An interesting one, if I fully understand it. Please explain why a scrapped part costs 3 times more to replace.
It's something that we've dealt with for a long, long time. When I was still in manufacturing, actually, our accounting people were explaining this in no uncertain terms when a part would get scrapped. In today's world, if I buy a piece of stock, I make a setup, I mount a fixture, whatever. Worse yet, if I have to build a fixture, I've got time and money invested in that. Now, if I scrap a part and catch it during the manufacturing process, and I've got a couple of extra parts that I can replace it with, you're not spending as much as 3 times the part. But I got to be honest, in today's manufacturing, our QC is solid today, but we probably don't catch that scrap part until the end of the production run. And if you have to break into a setup to finish out that order, you're spending 3 times as much money because everything that I just alluded to, you have to redo, plus buy more stock, plus the guys are always carefuler. They're a lot more careful when they try and fix the second part. And they will also spend time trying to fix the first part. And in the end, especially if it's a long-term production run, it's cheaper to throw that part away and add parts at the end of the production run.
Okay.
But financially, it works out to 3 times as much. I've fought that my whole life with the accountants, and they prove me wrong every time.
Well, twice as much is still 100% more than you really want to spend on a part, right? So
absolutely, and In a job shop situation in today's world, our margins are not that great.
Right.
So if you have to spend money to fix something that's gone wrong, but especially if I work for you and I've done it, that's not a good thing today.
Exactly. All right, here's another question. What about putting or having a VMC with a fourth axis? You didn't address that, just table operation, says this listener.
I understand. I get that question a lot. You're trying to build a horizontal machining centers, which all the Okuma horizontal machining centers and all the manufacturers today are standard with full fourth axis. I'm trying to take a VMC and make it a fourth axis. And I've actually tried to do that myself. It's simply not as efficient, one. Again, let's say that I can put a vertical machining center on my floor with a full fourth axis, and I can get to all the sides on the part at one time. I've built a special fixture for that normally is dedicated to that part. You can do a universal, but normally I see them as dedicated to that part. And I put 20 parts on there to amortize. When that vertical stops, the spindle stops, it's costing me money. From the time that spindle stops until it makes chips again. I open a door on a vertical machining center with 20 parts on the table or on a horizontal machine, on the fourth axis. It takes me 20 times as long to load and unload that part, and I'm losing money again.
And no one wants to do that.
No.
Time certainly is money, so is space, and so someone asks, how much floor space can we expect to save with a horizontal machine compared to a VMC?
In today's world, most of the VMCs I see being sold are 40 inches by 20, 40-inch X travel, 20-inch Y. That's a pretty common, we call them 40-20 VMCs. The average 40-20 VMC needs about 10 feet, maybe sometimes 12 feet, depending on the ancillary equipment setting around it, square. So I'm looking, we'll average that out and say a 10-foot square that machine tool needs to fit in. An average 500 millimeter horizontal machining center will generally set in maybe 10 to, let's say, 16 feet square. So it's 16 feet long and about 10 foot wide, give or take a foot or two because of the different types of horizontal machining centers. So let's say that I'm after replacing 3 verticals with 1 horizontal. The math is pretty easy. I'm taking up as much as 50% or more less floor space with 1 horizontal machining center than I will with 3 verticals.
All right. Now we are getting close to the end here, so let me ask this rather specific question, but I'm not sure you can answer it so specifically. What is the difference in price between a vertical machining center and a horizontal machining center?
Our reference again being just an average 40-20 machine. I'm looking, again, 3 machines versus 1 because of the productivity and throughput. On average, I'm going to see you spend 30% less on 1 horizontal machining center than you would spend on 3 verticals as a good round number.
Okay, that's pretty impressive. Of course, none of this is a hard and fast rule until you look at the specific situation, right?
That's very true. It can change with the operation. Some horizontal machining centers, you can only fit 1 very large part on the table. That percentage would go down, although it's still pretty close to that 30% number simply because I have the efficiency of horizontal versus 3 verticals. If I buy 3 big verticals, all that's happening is the numbers are going up. The percentage is going to roughly stay the same.
Okay. Now here's one last one that snuck in, but I think it's worth considering. Someone would like you to comment on vertical with an automatic pallet changer versus a horizontal machining center?
Okay, that's a fair question. Again, the first thing that I look at is I'm trying to get the same efficiency of a horizontal machining center with a vertical. An example, just a series of things. The first thing that I bring to everyone's attention, that the average cycle time for a pallet changer on today's horizontals, most of them are rotary, is only about 10 seconds. And some of these machines will change pallets with almost 1,500 pounds or 2,000 pounds on the table in 10 seconds. The average APC, or automatic pallet change, on a side-by-side vertical machining center today is about 35 seconds. So almost 3 times longer. It's not a rotary-style pallet changer. It is simply a side-by-side that quite often is not even servo-driven. It's hydraulic, which makes it even slower. And I still have all of the things that I've talked about with a vertical machining center, the drawbacks, if you will, involved in that. I'm simply adding the APC time to all those drawbacks.
Okay, well, that should do it for today. Our time is indeed just about up. Thank you, Jim. We just got a comment from one of the viewers here saying thank you very much. I learned a lot and appreciated this webinar. And he says he'll stop by at IMTS, so that's good news. And as Jim has shown, horizontal machining centers have numerous advantages. And yes, you can learn about these advantages by visiting Akuma America at IMTS in Chicago's McCormick Place, and that starts on September 8th and runs through the 13th. The booth number for Akuma is S8500, S8500 in the Metal Cutting Pavilion. If you'd like to learn more about IMTS, the September issue of Manufacturing Engineering magazine gives a complete rundown on each of the show's pavilions. Then in the October issue, the focus will be on shop floor solutions, while the December issue will concentrate on machining centers and cells. In addition, join us at FabTech 2014, November 11th through 13th in Atlanta, where you can also experience live equipment demonstrations and find cost-saving solutions. I'd like to thank you for joining us for this Manufacturing Engineering Media webinar. We hope you found it informative. Take care.